Today I'm going to be reviewing the Vatrer 51.2 volt 100 amp hour lithium iron phosphate server rack battery. Let me show you the accessory that it came with in the box. We got warranty card, user manual, battery cable, and this is size 6. And finally, a couple of L brackets to install it on the sides of the battery so you can mount it on the rack. The battery cable length is about 26 inches. Dimensions of the battery: 17.5 inches wide, 19 inches long up to this point, and 7 inches tall. Let's see how much it weighs. Oh man, that's heavy. And it weighs exactly 100 pounds. Well, actually, almost 101 pounds. This battery is completely sealed. There's no vent hole or anything like that on this battery. On the front, this battery design is very simple. You got the battery terminal, you got the screen, and a disconnect switch. That is it. There is a plastic separator between the two battery terminals. I wonder if these two terminals are connected, or are they really separated, because it looks like it's all insulated from each other. Let's find out with my continuity test. Yes, they are connected. Yes, we got a couple of heavy duty handles and they are foldable. And the good thing about this handle is they are made of steel and not aluminum. Down here we got a DC disconnect switch, and it is rated at 125 amps. Let's take a look at the screen here. It's got a single power button right here, and I cannot turn it on right now because the switch down here is off. So in order to turn on the screen, I have to turn on this switch first. Now that it's on, let's turn this on. It's not a touch button, it's actually a physical switch. And if I turn off the disconnect switch, this screen will also turn off. When the disconnect switch is turned off, it also turns off the output to the main battery terminal. So we got 0 coming out of the terminal. And let me turn this back on. 53.4 volts. Let's turn the screen back on again. On the screen, it will display the current output, battery voltage, temperature inside the battery, and time to empty. It's got 3 pages, so let's go to page 2. And also, this screen is not touch sensitive. It's actually a push-in screen, so you have to physically push it in for it to register. Now let's go back to page 2. On this page, you got a discharge and charge buttons. So when I push it, it will turn off the discharge function. Push it again. So it's not very sensitive, so I have to physically push it. It turns back on. Same for the charge function. So if I want to turn the charge function off, let's turn it back on. Down here we got battery capacity and cycle count. We got 2 cycles because I have charged this battery twice. Down here we got battery maximum and minimum temperature. Status of the battery. If there's any problem, it will show up here. BMS sats. I'm not sure what this is, and it doesn't explain in the user manual either. Let's go to page 3. It's showing the voltage of each individual cell. And it looks like all the cells are pretty much balanced. The difference is only 0.002 volts. And that is all about this screen. I think this screen is very useful. It shows the battery state of charge and also temperature, and the ability to turn on and off the discharge and the charge function. So that is very useful. This screen has a timeout function, and it will turn off automatically after about 5 minutes. This battery can be monitored by Bluetooth. So let me show you the Bluetooth app. This is the front page of the Bluetooth app. It shows the state of charge of the battery, remaining battery capacity. Down here, we got the charge and discharge function, but I cannot turn it on or off. Over here, we got balance off. Some batteries require you to cycle the batteries a few times before it can turn on this feature. Down here we got the protection, which is normal. If there is a problem, it will show up here. Down here we got general information about the battery voltage, the current input or output, power in watts. Down here we got the battery cell voltages. So we got the highest voltage, lowest voltage, and the voltage difference. Going down, we got the cycle count, internal temperature of the battery. Let's go down here. We got the cell voltage of each individual cell. So on this app, it's pretty much the same information as you can see from the screen in front of the battery. Let's go to page 2, about. And this is just general information about this app, and that is all about this app. The information on this app is almost identical to what you have on this screen. I have charged the battery to 100%. Battery voltage now is 53.59 volts. It's time to do a capacity test. We've got two capacity testers here. Each is discharging at 3 amps. So total discharge rate is 6 amps, and that's going to take about 17 hours to finish. Alright, it has been 16 hours and 40 minutes, and we already got up to 100 amp hours. So on the left we got 50.19 amp hour, on the right 50.3. so total capacity is over 100 amp hours already, but we still have ways to go. See, the voltage right now is 48.7 volts. The low voltage disconnect is down to 42 volts, so we still have ways to go. So it's going to be quite a bit more than 100 amp hour when it's done. So I'm going to be back when it's done. Alright, we are finished. The BMS just shut down. Battery output is 0.1 volts. Let's take a look at the screen here. We are at 0% and it needs to be recharged. The internal battery voltage is 39.4 volts. But the output to the terminals here is 0.1 volt. And let's see what we got. See the one on the left, we got 52.26 amp hour. The one on the right, 52.37 amp hour. So the total capacity of the two is 104.63 amp hour. And that's almost 5% more than the 100 amp hour rated capacity for this battery. That's awesome. It's time for a load test. This battery is rated at 100 amp maximum continuous discharge, and I want to see how it runs when it's under 100 amps. I've got a 4000 watt inverter connected to the battery. I've got a 1500 watt electric kettle and a 1500 watt heater connected to the inverter. The battery voltage right now is 53.43 volts. But on the screen it shows 53.35 volts, so that is a little bit off there. I've also got a fluke clamp meter here, and I want to compare the output on here with the one on the screen to see how accurate it is. Let's turn it on. Let's turn on the timer. Let's see what we got. Got 28.1 here. 27.9, 27.9. So that is actually very accurate. Now let's turn on the electric kettle. 61.3. 61.4. Wow, that is quite accurate. Yep, the amp meter on here is very accurate. 61.3, 61.2. Wow. It's been over 5 minutes and we are running stable at 60.9, 61 amps. Over here on the screen, 60.7, 61.6. So it's hovering around 61 amps, so that is still very accurate. 51.5 volts, 51.5. Wow. Now it is accurate when it's under load. It's almost 6 minutes now, and you can hear my water is boiling. Everything is running stable. It's pretty good, so it's time to turn this off. Let's push it to the limit, shall we? I've got my 48 volt DC stove and it's connected directly to the battery. This stove here runs at 110 amps and that will exceed the limit of this battery, which is 100 amp continuous. Now let's turn it on. 114 amps on the screen, 112.7. So that is very accurate. Voltage goes down to 50 volts. So let's put on the timer. It's almost 4 minutes and it's still going strong. 108 amps, 50 volts, and my stove is turning red hot. You turn off the light. Wow. Alright, almost 5 minutes now, still going, so let's turn this off. Let's push it a little bit more. I've got a 1500 watt heater and 1500 watt electric kettle plugged into the inverter. I've got 2 clamp meters. This one is on the inverter and this one is on the stove. Let's turn on the stove first. 113 amps. Let's turn on the electric kettle. 37 amps. Oh, it shuts down only about, I would say, 5 seconds later. So let's turn this off. Turn off the stove. Let's see how long it takes to turn back on. Battery voltage now is only 300 and 400 millivolts and going up. So let's see how long it takes. Let's put the timer on. Oh yeah, it's on. How long was that? About 7 seconds. I was a little bit late, so I would say about 15 seconds for the BMS to turn back on. So the total amount of current right before the BMS shut down, it was 110 here, 37 here, so total about 148, so close to 150 amps before the BMS shuts down. 150 amps on this battery is about 7,500 watts, and that's a lot of power. So there you have it. The battery runs just fine for anything below 110 amps. When you get close to 150 amps, you get about 5 seconds before the BMS shuts down. And then after that, it takes about 10 to 15 seconds for the BMS to turn back on. The BMS works beautifully to protect the battery from being overloaded, so that's awesome. It's time for a teardown. Let's open this up and check it out. It's got 16 screws around the top here. I already removed the screws and ta-da! Let's take a look inside the unit. My first impression, wow, this is so neat. Everything is nice and neat inside. You got the DC disconnect. This is the front screen. Let's take a look at the terminals here. These two they are tied together on the back here. Same here on this side. These two, they are tied together on the back here. We got the BMS and the Bluetooth module. On the negative side, we got two size 8 wires together, and that's equivalent to size 5. On the positive side, we got a single size 6 wires, and you can see it's glued to the switch by silicone so it doesn't get loose. Also glued on this side. All of the wires, they are insulated and protected by fiberglass sleeve, so they do pay attention to details. I'm going to open this up and we'll see what's inside here. Here is the inside of the battery, and it looks even more impressive inside here. It looks so clean. There are 16 prismatic cells, all of them connected in series, and the series connection is connected by a aluminum bus bar, and it's not welded onto the cell, but rather they use a lock nut, and that's to ensure that it doesn't get loose. Most other batteries will weld the aluminum bus bar onto the battery terminal, but this one uses a lock nut, and I like this better because if one cell goes bad, you can actually remove the cell and put in a new cell very easily. All of the balance cable are screwed down to the aluminum bus bar, and then they glue the screw onto the bus bar to ensure that this will never get loose. You can see every single connection for the balance cable, they are glued down to the aluminum bus bar. All of the balance wire, they are neatly tied together. I can see they pay really close attention to details. Now let's take a look at the BMS. The model number is SP16S020, and this is the BMS. It's made by JBD. It's a 16S 100 amp. This is a very popular and quality BMS. We got 3 connectors on this side. This is the balance connector, that's for Bluetooth, and that is for the screen. Up here we have the connector for the 2 temperature sensors. One of the sensor goes here, glued right onto the case, and the other sensor is glued onto the top of the battery, but it's not on the battery, it's on the plastic insulation. The reason why this heat sensor is not glued onto the actual battery cell is because the entire battery inside here is encased inside a plastic insulation. So you can see it's between the aluminum bus bar and the actual cell. All of this black part here is plastic insulation. And it's not just the top, it's also on the side too. So it's all the way around the entire battery pack. But I think this should be better to be glued onto the aluminum bus bar than the plastic down here. This will get hot first before the plastic does. This battery has cold temperature charging protection. The BMS will shut down charging when the battery is too cold to protect the battery from being damaged. I'm going to use a duster and cool the sensor to simulate the cold temperature. I've got my charger ready. Let's plug it in. Yep, so it's charging, and we're charging at 6.9 amps. Alright, let's try and cool the sensor. Oh yeah, it stopped charging. Let's warm up the sensor. Let's see if it's gonna resume charging. Oh yeah, turn back on again, and we're charging at 6.9 amps. So yes, it's working great. Now let's try the overheat protection. So let's see if it's gonna turn off if it's too hot. So I'm gonna use my heat gun to heat it up. Yep, it stopped charging. You can see the light turns green and we got zero amp. Alright, let's cool it down and see. Oh yeah, it's charging again, 6.8 amps, and the light turns red. So yes, the overheat protection also works. That's awesome. So there you have it, the Vatrer 51.2 volts 100 amp hour lithium iron phosphate battery. This battery is built like a tank and it's quite a good quality battery. It passed every single test I throw at it. I'll put a link down in the description if you want to check it out. And that is all for now. Thanks for watching and we'll see you in the next video.